In this video, we will be talking about the combined gas law. This lesson is part of the science concept of organic chemistry, and yes, we're going to tackle 4 laws, one of them being the combined gas law. So first I have to enumerate the 4 of them. First is the combined gas law. Second is the Charles law. Third is Boyle's law. And fourth is Gay-Lussac's law. These laws are all related to each other. So we're going to first start with defining the formula of the combined gas law. So P sub 1, V sub 1 over T sub 1 is equivalent to P sub 2, V sub 2 over T sub 2. As you can see, PV over T, that is the basis in between these formulas. The only difference is the sub-values. Usually, these laws are used to solve particular problems that are usually here in this part of the formula equation, the sub-values of 2. For example, before, after. This kind of scenario is usually in the questions of the exams in relation to this lesson. Provided that you have P, V, and T, which basically stands for, if you watched in the previous video, the one about ideal gas law, previous video, P is pressure, V is volume, and T is temperature. Now, moving on again, back to the situation, to the scenario that we're talking about. The problem usually specifies the pressure, the pressure, the volume, and the temperature. If not, we'll be considering them as constant. Some even being cancelled, just because they don't those variables are not specified in terms of their data. So we're trying to find sub value usually at the after. So provided that you have, for example, pressure, volume, and temperature, and the pressure sub 2 and temperature sub 2 solve for volume sub 2. So that is where the combined gas law formula kicks in. This is what we use in order to solve for a specific missing variable. So at least just one of them. Alright, let's move to the Charles law. What we have to know about Charles law is that pressure is constant. For Boyle's law, temperature is constant. For Gay-Lussac's law, volume is constant. Now, it might be hard to memorize these specifications in terms of matching these, correlating Charles' law to pressure being constant, Boyle's law correlating it to temperature being constant, and Gay-Lussac's law with volume as a constant. I think I have a technique that might help you, I hope, in memorizing and not misinterpreting or mismatching which variables are constant with which law. So all we have to remember is that, for example, for Charles' law, V sub 1 over T sub 1 is equal to V sub 2 over T sub 2. This is the actual formula of the Charles law. And for Boyle's law, we have P sub 1, V sub 1 is equivalent to P sub 2, V sub 2. So right now, we might be getting a pattern right here. Boyle's law, you always have to remember that Boyle's law is PV equal to PV. I think that could be easy to memorize. And with that, if you memorize the Boyle's law, you can already know or discern which formula it refers to Charles' law or Gay-Lussac's law. For Gay-Lussac's law, P sub 1 over T sub 1 is equal to P sub 2 over T sub 2. In comparison to the formulas of Charles and Gay-Lussac's law, we can observe that the temperature is the denominator of both sides. In that case, we could consider that Boyle's law doesn't have a denominator in its formula, while the Charles and Gay-Lussac's law has a denominator. And now, we can differentiate Boyle's from Charles and Gay-Lussac's. We can differentiate Charles and Gay-Lussac's law, considering that we have this is just a humble opinion. This might help, this might not help, but as for me, it does help to memorize it. Gay-Lussac's law, just remember that the numerator of the formula is P. And for the Charles law, the numerator is V. So, provided that you already know which formulas refer to which law, you can already determine which variable is constant. So for Charles' law, now that you know that V and T are in the formula, pressure is missing. It's not in the formula, therefore pressure is the constant. For Boyle's law, we can see in the formula that there is no temperature, there's only P and V, therefore temperature is the constant. For Gay-Lussac's law, numerator and denominator, they don't have volume, therefore volume is constant. So that's it. This is everything that we have to know in terms of the formulas of the combined gas law. I hope that you can understand these, because this is going to be what you're learning right now is going to be the basis on how you will solve the problems in regards to this lesson. Usually there are word problems. And you might want to refer to the previous video in terms of the variables that were discussed here, because you might not be able to, you might not know the variables that are installed in these laws yet. They're all in the ideal gas law video. I suggest that you check them out so that you could get a full understanding in regards to the gas laws. And yeah, hopefully you could also differentiate combined gas law and the ideal gas law. Just to make clear, combined gas law has this formula. It only involves pressure, volume, and temperature. The solutions revolve around volume, temperature, and pressure. On the contrary, the ideal gas law involves everything. It involves P, V, and T, but this time we have the Raoult's constant and the mole. So yes, I suppose that's it for this video. Again, complete information in the ideal gas law, our previous video before this. Especially for, you have to recognize the main units of each variable. It's all in the other video. Thank you for watching.